In this video, we'll take a look at how to deal with node types in Python. Node types in Python are a topic that can be a little bit confusing and unintuitive, so we're going to create a tool for it. So first, let's identify another weakness of our setup, and that is that we have an awful lot of these control point nodes. Now, what if we had like 100 control point nodes, and each control point node had a bunch of nodes underneath that were used to change attributes on it or whatever, and we needed to be able to select all of the control point nodes. This might be kind of difficult, especially if they're not all right in a line. What we could do, however, is create a shelf tool where if we select one of these nodes, we then run the tool, and it selects all the other nodes at the same level of the same type. So essentially, we select one of these control points, it selects all of the other control points here. So how would we approach this? Well, let's go ahead and create our shelf tool. New tool. We'll go to options, we'll call it select type, and the label will just be select type. Hit apply. And then the context, we actually want it to be all of them. So let's just go ahead and select all of them. And this is because this is a tool that could be useful anywhere. And for tab submenu path, once again, let's say Python class, and hit apply. So now if we put our cursor into the network editor and hit tab, under Python class we see two different tools. The create outNull tool that we created before, and the select type tool. Alright, so now we are ready to start creating our tool. So if we go back to the script tab, the first thing that we're going to need to do is get the type of the control point node. So let's just go ahead and do some tests. So if we grab this control point node and we drag it in here, we'll just use that one to test with. So we'll say n equals. So basically we're just going to dump the node object for the control point 2 node into this variable n. And you may be noticing that again I'm using a single letter variable, and that should tell you that we're going to end up deleting all of this when we make the actual tool. But for now, let's just take a look at how to deal with types in Houdini. So the simplest way to get a type is using the type function on the node object. So we say print n.type, open close parentheses, and we hit apply. We can click select type, and it will give us who.sop node type for sop control point. Notice that it gives us all of this information, and that means that the type contains all of this information. So it knows that it's a sop, and it knows that that sop is the control point type. So if we hit clear and close. Now, the weird thing about this, though, is if we want to compare things, well, the simplest way to compare type names is by simply using the name of the type. So we could say print n.type in parentheses equals control point. So that's a control point type. Now this actually won't work, and I'll show you why after we demonstrate that it won't work. If we hit apply and click select type, it says false, even though control point is actually the type. So the reason for this is that we're trying to compare a type object to a string. So Python's taking a look at this and it's like, well, it's a type object, and this one's a string, so no, they're not the same. So the way that we actually get the name of the type is the type object has a function called name. So if you say dot name, open close parentheses, and what this will do is it'll return a string representation of the name, which should be control point. So if we hit apply and we type, and we click the select type button, now it's true. So the way that this works is we call the type function on the node object, and it returns a who.sopNode type object. And then that object has a name function, which returns a string representation of the name of the type. And then we can compare it with a string. This is the simplest and least sophisticated way to do type comparisons in Python. Now, there is one weakness to this method, however, and that is that if you have two node types that are called the same thing but exist in different contexts, so say that we had a control point that existed in the object context, Houdini will totally allow that, and this this method of comparing types doesn't actually account for that. So in that case, we want to actually compare the type itself to another type object. So we'll need to get the type object for control point independently of just giving it a string. So let's go ahead and see how we do that. So let's delete all of this and see how we can just get a node type. So if I make another line here, let's say print. So the way we do this is we do who.node type, so lowercase n and a capital T, and open parentheses. And this is a function on the who module that returns a type object. So notice that it's asking for a category here. And the category is basically the context, so it's whether it's a SOP or an object or whatever. Now you can't just give it a string that says SOP, because Houdini actually wants an enumeration value. So the way that we get a type category is we just do node type categories, that one. Open and close parentheses. And this is a function, again on the who module, that returns a dictionary of node type categories. So now we can just give it SOP to read that out of the dictionary. And then the second argument that who.nodeType is going to ask for is the name of the type. And in this case, we can just give it control point, close parentheses, and there it is. If we hit apply right now, and we click select type, notice that it's giving us a who.sopNode type. That's this print statement here. And this one is giving us another who.sopNode type. That's this print statement here. So we would expect that if we dump this into a variable, let's say t equals, so we're going to dump this node type into a variable. We would expect if we say print n.type equals t, hit apply, let's hit clear and close on our console here. Now if we hit select type, it gives us true. Because in this case, we're comparing one type to another type. Now this way of getting the node type category out of a dictionary is kind of cumbersome. So Houdini's actually given us a way to, a shorthand way of getting there. So if we delete that and say who.sopNode type category, this is a function that just returns the SOP node type category. I think this is easier. However, if you ever want to see all the different type categories, you can just print out that who.node type category function, and that'll tell you what all the categories are. Alright, let's hit clear and close on this one. Okay, so now that we know how to compare types, we can actually make our tool. So let's go ahead and just delete all of this code and start in our tool. So the first thing that we'll need to do is loop over all the currently selected nodes, because we want to select a node and have it select all the other nodes of that type. So if we loop over all those nodes, we want to do selected nodes equal who.selected nodes. And now this variable will contain a list of all the currently selected nodes as node objects. And then to loop over them, we would say for node in selected underscore nodes. And now our node variable is going to be our currently selected node. So the first thing that we're going to need to do is we're going to need to get the type of this node that we have selected. So let's say node type equal node.type. And remember that this type function returns a type object. So this has all the information that Houdini can give us about the type of the node. And then next, we'll want to perform a comparison against all the other nodes at the same level. So how do we do that? Well, we're going to need to loop over something. And in this case, what we're going to want to do is we're going to want to loop over all the children of the parent node. So essentially, we want to go up to /obj/explosions, say, give me all the nodes inside there, and then loop over them. So first, let's go ahead and get the parent node. That'll be /explosions. So we'll say parent equal node dot. I could do node dot node again with the dot dot, but in this case, I'm just going to say parent open and close parentheses. And this is essentially the same thing as saying node dot node dot dot. It's just saying give me the parent of that node. So the way that we get all the children of a particular node is with the children function. So we could say for child node in parent dot, and then just say children. And this again will return a list of all the children contained by parent. So it'll essentially be all the other nodes in this network, including the one that we have selected currently. Which isn't a problem in this case, because it needs to stay selected once we run this tool. Okay, so the next thing that we need to do is we need to do our type comparison. And in this case, we actually have node type objects, so we can just directly compare them. So we can say if child node dot type equals node type. Remember that node type is the variable which we defined up here, and that contains the type of the node that we currently have selected. And then what we want to do is just set selected if it is. So we say child node dot set selected true. Maybe not typo. Okay. Alright, let's hit apply and see if it works. So if we select this guy and say select type, there we go. It selects all the other types. This tool can be incredibly helpful for managing very large networks. So if we step through real fast what this is actually doing, the first line, we're getting all of the selected nodes. Then we go down to our for loop, and it says, I want to have this node variable contain the currently selected node that I'm looping over. Then we store the type of that node in a variable called node type. Then we simply get the parent and dump it into a variable called parent. And we get that so that we can loop over all of our selected nodes' siblings. So this is where we do that for child node in parent.children. It's essentially saying I want this variable child node to be the current child that I'm looping over. Then we do a type comparison, so we say if child.type equals node type. Remember, this node type variable is the type that we defined up here. And then if they are equal, we just set selected to true.